go through the solutions of the homework that you had on Thursday, which was more irritating than difficult, I'd say. I apologise, actually, when I first looked at these questions, I didn't realise the measurements were things you had to measure yourself. It'll just take you an extra little bit of time to do it, and harder to do it from the screen. So you would have needed to find your book or your ebook and do some measurements. So here are the measurements, and you might have gotten them slightly different to this, but in question 1, I've just sketched it out here, my vertical height. So the first vertical height here is 0 millimeters, and that's really important that you get those 0 millimeter ones correct. This one was about 23 millimeters, this one 28, 22, 23, 28 and 20. Now mine is not drawn as accurately as what's in the book, it's just to illustrate the idea of it. And it was 10 millimeters across each of the segments. Here were the same distance, and that is always the h in our formula. Then the trapezoidal rule allows us to approximate the area, and we've got a long looking formula in the log tables, but the easiest way to remember it is that it's h over 2, and you add the first and the last vertical heights, and then you add up all of the rest of them and multiply it by 2. So that's not the formula that's in the log tables, but it's the one that's easier to remember. H, of course, is the distance that's the same all the way along, so that's going to be 10 over 2. The first vertical height is 0, that's why it's important to get that 0 in there. If you skipped onto this being our first vertical height, you're not going to get the right calculation. My last one is 20, plus twice everything else, 23 plus 28 plus 22 plus 23 plus 28 plus 20. And there are no marks going from working that out step by step. Excuse me. Excuse me. There's no marks going for working that out step by step, so it is fine to just type the whole thing into your calculator, but I do recommend you might do it twice just to make sure that you don't make any errors. And that should have come out to be 1,340 millimeters squared. Okay, there's an extra piece of the question though. Have we answered the question? Give your answer in hectares correct to 2 places of decimals. Well, this isn't in hectares, it's in millimeters squared. But they told us that 1 hectare is equal to 10,000 meters squared. And we're also told that the ratio is 1,000 is to 1. So that means that the true, sorry, that's gone off the screen there. That means that my true area here is that this corresponds to 1340 multiplied by 1,000 millimeters squared. Now we need to convert our millimeters squared to meters squared. And we know, converting to meters squared, we know that 1 meter is 1,000 millimeters, so one square meter is 1,000 millimeters squared. So we don't just divide by 1,000, we have to divide by 1,000 squared to convert millimeters squared to meters squared. And that means that this is going to be the same as 1.340 meters squared, which is, then we have to go even further. So to convert it to hectares, to go to hectares, we have to divide again. And this time we're using this formula here. So these ones are already in meters squared. So I'm dividing by 10,000. And we can write this in scientific notation, or you can just write it in decimals. Let's see now. And the question said to 2 places of decimals. 1 meter squared. No, sorry. I think I've gotten something wrong in my conversion here. Ah, yes, I apologize. So the ratio was in meters to millimeters. So actually, I should have just divided by 1,000 here. My apologies. I should have just divided by 1,000 here, which would have given me 1,000 meters squared. And then to divide, I've written it down wrong, sorry. This should have been 1,340 meters squared. I'll go over this again now in a second. And then I have to divide by 10,000 to get my hectares. So it is 1,340 divided by 10,000, which is 0.134 hectares. 0.134 hectares. Okay, and the question asked for that to 2 decimal places, so that's approximately 0.13 hectares. Just make sure that all of that's on the screen. That's not the bottom part here. Okay, so let me explain what's happening there. My ratio was 1,000 millimeters is to 1 millimeter, which means that to get 1 millimeter squared, it's going to be 1,000,000. So I have to square my 1,000 there. Which means that when I did my conversion here, this was in fact 1340 and another 6 zeros after that, millimeters squared in real life. In real life, not this one. And then yes, I should have divided by 1,000 squared to get it to meters squared, which gives me 1,340 meters squared. And I just skipped here because I knew that the extra 1,000 that I should have multiplied by here matched the extra 1,000 that I divided by here. So that's what's happening there. Now, maybe when we're talking on Monday, I can go through this conversion again if somebody is still feeling a bit confused by it, because I've kind of messed it up by going over it twice. Anyway, the answer is 0.13 hectares when we convert that to real land area. Okay, question 2 then had a similar kind of question. This time, however, they provided the measurements for us. So the first thing that we were asked to do was calculate the estimate of the area. I'll just move this up a little bit. So again, the area is going to be h over 2 by the first plus the last plus twice the rest. So do write down what you fill into that formula. We are told that the distance between the segments were 1 centimetre. Yeah, the distance between them was 1 centimetre. So this is going to be 1 over 2 multiplied by, and again, my first vertical distance is 0 again here. I'm sure you can see this on the screen. This is moving around a little bit, sorry. So we have 0 plus 3.66 plus twice all of the other vertical heights. 2 plus 5.42 plus 3 plus 1 plus 4.36. And then we just put that into your calculator in one go. And the answer comes out to 17.61 centimetres squared. So that was the first answer that we wanted there from the information that they'd given us. The second thing we were told is that the area of the map, the actual area, the true area, was equal to 17.23 centimetres squared. So that doesn't match the calculation that we have here, and they've asked us to work out the percentage error. So first of all, the error is the difference between the two values. So that is 0.38 centimetres squared, and then my percentage error is going to be this error. And when you're doing percentages, it's always the true value or the original value that you use for the bottom number, and then we multiply that by 100. So the percentage error that we get is 0.38 divided by 17.23 and multiplied by 100, and that is 2.2. How many decimal places did they ask for? They didn't say, so we'll go to 2 decimal places, 2.21% error, approximately. So this here, the error was 0.38, the true value was 17.23, and then we're multiplying by 100 to calculate our percentage error. Okay, the second part of the question then involved us doing measurements again to find a second estimate of the area, and what we'll notice is we should get closer to this value when we take smaller segments here. So this time when you did your measurements, it should have been approximately this. Remember, every second one is going to be the value that they gave us here, so you didn't have to measure that. So the 2, the 5.42, the 3, etc., etc. These were the other measurements you would have gotten, more or less. So when you calculate the area here, we have more segments to deal with, but now the distance is no longer 1, but 0.5 over 2. So your new h is half. And then the first value is 0. The last value is still 3.66, so those haven't changed at all, plus twice the rest. 0.9 plus 2 plus 3.9 plus 5.42 plus 4.7 plus 3 plus 1.9 plus 1 plus 2 plus 4.36 plus 4. So again, it's fine to just put this into your calculator in one go, but do it twice to make sure that you don't have an error in your calculation or in what you've typed into the calculator. And this should come out as approximately 17.505 centimetres squared. And that's a little bit closer to the true value. So we're coming closer and closer to the 17.23 as you take smaller and smaller increments. So it's getting closer to the true value. So if you could take teeny tiny increments on your map, you made those smaller and smaller and smaller, you'd get closer and closer and closer to the true value, which is an important thing that we need to remember for when we're doing integral calculus next year. Okay, hopefully that didn't take you too long with all the measurements and everything, and you understand how to use the trapezoidal rule formula correctly. Thank you.